Most commands in R are functions. That is, they take inputs and produce output. The first function we'll examine in this video is the combine function, which accepts multiple inputs separated by commas and outputs a vector whose coordinates are the inputs. The lowercase c calls the combine function. For example, if we did a C2, 3, -4, 5, 6, 7, that returns a vector 2, 3, -4, 5, 6, 7. In the panel it looks like that. R printed the output to the screen because we didn't tell it what to do with that vector. A convenient feature of R is the ability to retrieve a previous command line. This is done by pressing the up arrow, which I'm doing right now. That just brings up that last command that we had. We'll create objects in R that can be used again and again. An object is created by naming the object followed by an equal sign, or a less than or equal to a less than sign and a subtract sign, and a function that creates what is to be stored in the object. For example, we can edit our previous line as I have here to create an object v1 that contains the vector produced by C. The R panel then looks like this. You'll notice in this time that R did not print a result because the output of C was stored in the object v1. A very useful function that operates on vectors is length. The length function takes a vector as input and outputs the number of coordinates in that vector. If we do length on v1, then we get what's shown there. To illustrate some of the arithmetic that's available with vectors, I need to have another vector. So I'll create v2 at this point. v2 is a vector that contains 1, 2, 3, 4, 5, and 6. Notice that the length of vector v1 is the same as the length of vector v2, as demonstrated there. So far we've created two objects, v1 and v2. As our workspace becomes more complicated, it's important to be able to see what objects have been created. The ls function gives us information. If you do an ls with no input, then it gives you a list of all the objects that have been created to that point. Because these vectors v1 and v2 are the same length, they can be added, subtracted, multiplied, or divided, as illustrated here. If we take v1 plus v2, you'll notice that it just adds them component-wise. v1 times v2, it just multiplies them component-wise, and so on. Another function that operates on vectors is summary. This function is very useful in statistics because it gives the 5-number summary of the sample, assuming that the vector is the sample, as well as the mean of the vector components. So for example, summary v1, as you can see here, it tells us what the minimum is, what the maximum is, the first quartile, the third quartile, the median, and the mean. The function mean also operates on a vector and just simply gives you the mean. You'll notice that those two results are the same, except the mean carries the decimal points out a little bit further. R allows us to add or subtract a number from a vector, returning a vector where each component is either increased or decreased by the value of the number. Here's an example. Suppose that we take V1 minus the mean of V1. Of course, the mean of V1 is just a number. V1 is a vector, and it returns a vector where each coordinate of the vector has the mean subtracted from it. R also allows us to square a vector, which returns a vector with each component squared. For example, using the up arrow key again and editing this vector, we get a new vector with each of the coordinates squared. Another useful function is sum. This function takes a vector as an input and outputs the sum of the coordinates of the vector. This is illustrated by, we'll take that last vector that we just had and put it into the sum function, and there we are. An alert student may have noted that this last calculation is what statisticians call the sum of squares. For convenience, we will construct an object called ss.v1 to mean the sum of squares, and I'd like it to be equal to that last calculation that I made. It might be easier to do this, retrieve that last calculation, and then sum of squares of v1 is equal to. Now it'll be useful just to see what we've got here. Notice that we've got those three objects, the sum of squares of v1, v1, and v2 at this particular point. We use the sum of squares to find the sample variance. The sample variance is the sum of squares divided by n minus 1. We can do that calculation now. We've got that sum of squares, v1, divided by the n, which is the length of v1, minus 1, and that, sure enough, that's the sample variance. It's not surprising that R has a function that will produce the sample variance, a function VAR, that calculates the sample variance. VAR of V1, of course, gives us that same result. Okay, we'll examine more properties of R in the next video.